Quick intro, right, of Optimal Dynamics. So who are we? What are we doing at Optimal Dynamics? The Optimal Dynamics was founded from 40 years of research and development at Princeton University. And that team was tasked with how to solve complex problems and make decisions leveraging computers when we're working in uncertain environments. So that work really focused on decision automation and logistics, and Optimal Dynamics became a decision layer for logistics that helps truckload operations make better strategic and operational decisions in the face of uncertainty within their networks. And they're leveraging Optimal Dynamics as well as AI machine learning to do that. So that's what we mean by truckload planning reimagined, and we'll talk more about that. So based on our topic for today, in case you missed it, right, supply chain is the #1 topic globally in the news, across the country. We see headlines every day. And now we're seeing the truckload driver shortage start to show up in more and more of that kind of news cycle, so that we see that this is a vital link in our supply chain. Truck drivers are now considered critical infrastructure for the country, for the economy, for the supply chain. And they're finally getting sort of the recognition of the impact that they have on our overall supply chain and economy. So one thing that you're seeing is new programs and government say agenda around how can we improve the truck driver shortage, whether it means trying to introduce a new generation, a younger generation to truck driving, or as you've seen with some of the things where we have the ability to have younger drivers in trucks in the seats with a new program, and also agenda and policy around improving that truckload workforce and strengthening it to improve our supply chain. So with that, if you look at the top challenge for fleets, whether it be for hire, private, dedicated, the #1 challenge by a long shot is drivers, right? And the ability to recruit and retain drivers is #1 on that list. And if you look at fleets and their typical driver turnover for a for-hire fleet, you could see that average in the 70s to 100%, depending on, say, the size of the fleet, and what type of operation they have, regional versus over the road. So with that, we take another level deeper and we try to say, okay, what drives satisfaction? What can improve retention for drivers? And so some studies show, right, that the way drivers rank this is based on stability, improvements in their income, their schedule, flexibility, the types of routes that they get, the types of hours, and ability to make decisions around what they accept and don't accept for their loads. All of those things are very important to drivers. And the different providers out there are typically pulling levers around driver pay, planning and scheduling for the drivers, trying to build a better feedback loop with the drivers so that they make sure that any changes that need to occur to improve sort of satisfaction on the job continue to be made, recognizing drivers for their performance, for their longevity and loyalty for the company, as well as training them, giving them new skills, improving their opportunities that they can haul and work on, as well as new technology and equipment, right? The better tech, the better equipment that they can use to improve that quality of life on the road, and other safety programs to decrease the risk associated with the job. So one area that we see that actually does tend to show an improvement in driver retention is time at home. And we see this really well with private fleets. So oftentimes with a private fleet, the drivers are home, say, every day, every couple of days. And so they have this better quality of life around not being on the road as long. And really, when we look at that driver turnover for private fleets, we see that in the 15 to 20% range. And it's, at least somewhat related to that time at home. There are other factors with that private fleet that may improve that turnover. But if we were able to say, okay, let's take a for-hire fleet that's doing a week or 2 weeks on the road, try to improve that, get it down to maybe a few days rather than a couple of weeks. Now we might be able to see that driver turnover move from, say the high 90s or 100% to somewhere in between this 20, 15% and 100%, and get that driver turnover down and improve retention for those for-hire fleets. So how do we do that with Optimal Dynamics? So with the Optimal Dynamics platform, we really take an approach where we do that with 3 different capabilities. The first is strategic simulation. So when you want to look at changing something about, say, your driver policies and retention strategies, whether that be pay, whether it be time at home, you want to have a simulation, a digital twin of your network, and you make those changes to how the drivers operate, how you pay those drivers, and understand what the impact is to your network. So if I make this change, how does it impact my revenue, cost, profit, service levels? How do I make different decisions if I'm trying to get these drivers home every day? You simulate that with the strategic simulation, and it gives you a really, really detailed understanding of the impact of the network to customers and service levels and drivers across the entire network. Then once you've made those decisions around what types of strategies you want to put in place, you would then operationalize that through our tactical load acceptance. And so now when you're making decisions on what loads to accept and to run on the fleet and what drivers might make sense to take those loads, you're taking the decisions that you've made around policy for your driver retention strategies. Let's say they get home every 4 days instead of every 7. Well, now I need to make sure that when I accept my loads and I'm looking at the loads that come in from tenders, that I'm making decisions that get my drivers home within that time. And now what I try to do from a strategy perspective is operationalize leveraging load acceptance. Then once you get closer to the actual move of the load, you make decisions around what driver, and we automate that driver assignment based on the ability to consider that new time at home strategy or any other types of policies you put in place for driver retention. So you simulate it, you then make decisions around what loads and freight you're going to take based on those driver retention strategies, as well as dispatching and assigning drivers to improve that driver retention. So we're going to go into it a little bit deeper, and we'll go into our strategic simulation to give you an idea of how you could do this. So what you see here is a view of what our strategic simulation looks like. And then on the right-hand side, some of the analyses that you might want to do within the simulation to understand the impact on your network for driver retention. So of course, pay, we always talk about pay. And we've seen that pay may or may not impact driver retention, as we see the pay increase and sign-on bonuses just kind of tend to lure drivers away, and they pop in and out of networks. So sometimes it works, sometimes it doesn't. And then time at home, which we have seen does have an impact, like with the private fleet scenario. The location of the driver, right? So depending on where you recruit drivers and the freight in your network, it can have an impact on the ability for them to, say, get home on time and improve their quality of life and the routes that they take. Of course, the number of drivers in your network can affect driver retention strategies. So let's say you have more time at home, maybe you need more drivers in the network, depending on how your freight is laid out. Then when it comes to bidding and what lanes you should bid on and what freight you should try to move with your network, you also want to keep in mind, what are those driver retention strategies? So if I get a bid, I can plug it into the strategic simulation and understand, okay, which lane should I take to make sure that I'm actually operating with the policy of, say, getting them home sooner, or what should my pricing be if I increase pay? And there's other things you might want to consider, like a relay network. Where are your relays and how can that affect the ability to get the driver home more frequently? What are your existing lanes and customers? How do they impact the ability to improve that driver retention, as well as just the loads you're accepting, right? If you looked at all the loads you accept versus reject, maybe some of those loads that were rejected would actually improve some of those driver retention strategies. Some of those loads you accepted might want to be rejected just to make it easier to, say, get them home, or to make it more profitable based on the changes in pay. So now we'll go into the platform and we'll look at a strategic simulation to give you an idea of how you would do this. So switch over. So on the screen, you can see what would be a simulation of your existing network. So this would be a baseline digital twin of your network, where we're looking at some sample of data, in this case about a month of data, where we're saying, all right, if I plug in that data, how does that look from a cost, profit, service? What are my drivers' typical activities? What's their typical time at home, miles per week? Of course, you can see those metrics across the top at a high level for the network. What are their empty miles, loaded miles, all the above. Then on the map, you can see every flow within the network. You can understand the direction, the quantity and volume on those lanes, as well as you can drill in and see more and more detail as you go into the map and zoom in. On the bottom, we see that time horizon. You have, of course, the ability to kind of change the time horizon, look at, say 1 day or 1 week versus a month, and change what you're kind of viewing on the map and your metrics. As we go over to the right, we can see the impacts of each individual customer or shipper. We can see each individual lane in the network, whether you want to view it by city, state, or by zip. And if we expand that view, now we can see additional metrics on those individual customers. How many loads, what was their impact to profit to the entire network, not just say loaded miles versus revenue and cost, but also all of the empty moves that you make to support that customer and that impact to profit, your revenue, your service, how much of that you're covering on the fleet, as well as loaded miles on time. All of those details are there in the simulation. Then, of course, you can go over and take a look at it from a driver standpoint. I can see every driver location within the network, domiciles or driver home locations. I can see a breakdown of the types of drivers. So if you have over the road versus regional versus local, all of those breakdowns you'll see here. Then if we expand, you'll see details on each individual domicile or home location. You can see the average miles per week out of these locations in the country, empty mileage, time at home. So now you're able to start breaking down your network and understand, how you're operating across each individual driver, across each individual location in the network. If we wanted to go in and dig deeper, right, I can look at it by individual driver and see the actual moves for an individual driver over, say, this time period, and see their averages per week and what we're getting for time at home, what we're getting for mileage. And if we go back out, of course, we can see that driver's activity for that week on the map, unfilter, and we'll go back, we'll see all locations and the whole network. So if we wanted to do an analysis and see, okay, how would this network look if I changed my time at home? So, potentially time at home now for this network is, say, 7 days, but I want to look at it every 5 days. I'm going to get them home, or every 3 days, I'm going to get the driver home. So if we want to do a run, we come here, create a scenario, test the time at home, save that. Then when we come into our driver view, now I might go in and change the driver types. So here I'll go to a specific domicile or driver location. And I can see, hey, I have a time at home every 7 days, time at home every 5 days, time at home every 3 days. Can go in here and just edit that so that whenever we look at our time at home, we're able to see, let me bring that back up. We're able to see our total driver count, and we're able to edit how many drivers of each type we have there. So again, add more to time at home 5, take them away from time at home 7 or time at home 3. Or if you had different pay structures, right, you could change the pay structure. Say, I want to put my drivers in this pay scale 2 versus pay scale 1, or I want more local drivers versus regional drivers. And then when we make those changes, we save that, and now we run a new simulation. So if I say change them from 7 days to 5 or 5 days to 3, every 3 come home, I make that change and then run the simulation. So from there, we do have the ability to go in and look at a scenario that we've run. We have a base case, which is history. We have a more time at home, and we have a most time at home. So, base run, we're looking at every 7 days, trying to get home, say once a week. More time at home, trying to get them home, say every 5 days. And then most time at home, try to get them home, say every 3 days, like twice as much. So if we want to look at the impact, right, we can take our base case, our historical current day simulation, and compare that to, say, more time at home or most time at home. So if we go, say, just a couple of days more frequently, how does that impact my overall profitability? How does it impact the number of loads I can cover? And then also, what's the impact by customer? So I can go in and I can look at each individual customer and I can see, okay, for this customer, I took 19 less loads if I send my drivers home, say, 2 days more frequently, right? 5 days instead of 7 days on the road. And I can understand the impact by each individual customer or lane. Of course, we have that view on the lane side. If you want to look inside of a certain customer, you can then see a breakdown by each individual lane for that customer. So again, if I'm coming home more frequently, now that leaves me potentially unable to do some of the loads that I was doing in the past, right? And you can see the impact. Of course, you could also see, do I need to increase revenue on this customer? So you could make a change to the revenue for a customer or a lane to make sure that you're able to cover that if you're changing driver pay or if you're doing more empty miles to support more time at home. Also on the map, you'll see again that, say, that customer lane set, or if you went back out, unfiltered this view, you'll see again a view of the whole network. And anything in red is going to be a lane that, say you took less loads on. Anything in blue, you took more loads on. So you're able to see the exact delta between your historical and your more time at home scenario and what the impact is. And you can also go in and see what that looks like from an individual driver perspective. So if we go into the home locations and the drivers, now I can see exactly how much that changed time at home. So we can see the increases in time at home, for example, here from, say, 50 hours a week to 76 per week. Right, so that time at home, more time at home, is going to show you the impact also on empty miles, how many miles they're able to do average per week. And you're able to understand at a very granular level how making those changes to driver retention strategies, which ultimately improve your driver turnover, impact your network. So if we kind of go through this process, right, you would see how maybe changing your decisions on bidding would look from a strategic standpoint, changing your decisions on pay, driver location, number of drivers, time at home, all of those things you can analyze here. The next question is, how do you operationalize that? So within Optimal Dynamics, you're able to take those simulations of your driver retention policy strategies and put those into operations so that when you make decisions, you're actually making them with that change in mind, or that new time at home, or new pay, or let's say, new, say, routes and number of miles per week or loads per week that you're trying to give the driver. So all of those things get made in real time in the platform as well from an operational standpoint. So an example here would be, I've got to make a decision between two loads that came in today, right? And so I have a load going to the Midwest, and it's going to give me a higher profit or savings maybe versus one way if I'm a shipper fleet versus a for-hire fleet. And then I have a load to the Northeast. It looks like that load is a lower profit savings. So naturally, I'm trying to get this driver back home to Texas. I might go in that direction a bit and take the higher profit load. So I'm just making a decision here just based on profit and just sort of high level decision making, hoping that I'll get this driver back home within time for, say, that new 4 or 5 day time at home versus 7 that we had looked at previously. So when I do that, take that load up to the Midwest, have a short empty around the Midwest, get my next load, again, make the same decision on what to take just based on, say, profit and a high level estimate of when I need to get home, but it takes me back to the Southeast. Then I make the decision again, and that load takes me back up to the Midwest, maybe even further from home. And now all of a sudden my decision is I have to send them home with a long empty because, I took that load up to the Midwest. Whereas if I was able to make a different decision and look at the load going to the Northeast, I could see that, okay, I'm going to have a short empty around the Northeast, maybe a haul over to the Midwest, then some loads down to the Southeast or closer to Texas with shorter distances to home, right? With the decision in mind that I'm going to get this driver home within that new retention strategy and policy that I've created. So if we compared those two different options, we would see that overall that second option actually gave us a higher profit and savings versus the previous one, which was, you know, 650 versus 350, mainly because we didn't have such a long empty home because we had to get them home with that new driver retention strategy. So when we're making these decisions around what loads to accept on a real-time basis, you need to be able to consider loads that potentially are not even in your network yet, right? They haven't been called in. So anything in this scenario in gold, we actually didn't know yet. So here, Optimal Dynamics is leveraging machine learning and also the decision-making capabilities within the solution to decide, hey, I should take this load because I know that other opportunities are going to show up in my network in a couple of days that will get this driver back home profitably within the new policy that I have for driver retention and improving, one, my overall operation, as well as my driver retention and driver turnover. So now I'm making decisions on what loads go in the network based on those new driver retention strategies. So, you know, what's the way that we're able to do that? As you saw, we had a lot of loads that we had to forecast, right? We had to learn and predict what's going to happen in the network. And really what we do with that is we create a much larger problem to solve. You know, typically you're only solving based on the loads you know, but now if you introduce many simulated loads that don't exist and you have a lot of different scenarios to choose from, you have a much more complex problem, a much larger problem to solve. So leveraging high dimensional artificial intelligence and approximate dynamic programming within Optimal Dynamics, we're able to, one, create that much more complex problem, to simulate the uncertainty in the future and make better decisions based on that. But we also can solve that very quickly. And that's really the differentiator here whenever you're trying to make those planning decisions and automate those complex decisions in uncertain environments. So again, we talked about this a little bit, but the strategic simulation, once we make that change to that driver policy, we can sync that over to the operational side so that when we're making decisions about load acceptance and what loads to take, and also, you know, what driver should take that load, we're making those decisions with those new policies in place. So as soon as you decide to make that switch from driver comes home every 7 to driver comes home every 5 or 4 days, that can actually be operationalized directly within the platform. So how do we do that? We come back, I'll go over to the platform again, and we'll show within, let me get out of full screen here and go back a tab. Within our platform, what that looks like from an operational standpoint. So now I'm looking at every single load that's come in, right? And I'm making a decision on whether that load should go on the fleet or whether that load might go to the brokerage or say a one-way if I'm say a shipper fleet. And here we can see all the decisions that we've made. So in real time, we're looking ahead into the future, like we saw, to understand what potential loads would show up in the network and how those potential loads would affect our decision to accept or reject a load. So here, all of these loads have been accepted on the fleet. We can see a load score, and that load score really comes from all of our simulations of the future. So all of these forecasted scenarios of the fact that the driver should go to the Northeast versus the Midwest, and how those loads are going to pop up that they can take to get them back home within that new strategy that you have for driver retention. So also you'll see what are the potential drivers, right? So when we're simulating that and the fit for the fleet, we're also seeing exactly which driver might take that load. So here we can see a couple of different drivers as options. And if we go a level deeper, we can now see every single future simulation of how that driver might end up grabbing that load, say 2, 3, 4 days from now, as far out as say 3 weeks into the future, to give you an idea of what it's going to look like whenever these loads pop up in your network and what a driver is going to be doing. So again, this goes back to how do I simulate the future to make better decisions? And you're seeing those different simulations as forecasted loads here live operationally, so that when we're saying, take this load, put it on the fleet, put this driver on this load, you're actually accounting for what's going to happen in the future and not just the loads you know at the moment. So from there, you can also go over to dispatching, where now it's actually assigning the individual driver to the individual load in real time. And you're able to take your driver retention strategies and policies, and you're able to operationalize them automatically. So we took loads that made sense for these new policies, and now we're assigning the driver from an optimal standpoint across the network with uncertain future in mind, also with those new driver retention policies in mind. So now you're taking from the strategic to the tactical to the real time. I simulated it. I now accept my loads based on that policy, and now I assign my drivers based on that policy. And it takes you from, sort of a pie in the sky, what is a driver retention strategy going to look like for me, to this is how I execute on that strategy day in and day out. So from there, we'll go back. How do we do that? How do we connect to your systems right now? And where do we play within that? So again, as we talked about, optimal dynamics being a decision layer. And so if you look at, say, core systems like a TMS or a WMS, systems of record, those systems would still be part of the decision-making and the processes for all of the fleets. But now they have real-time signals as well for location, GPS, for driver hours of service with the LDs, IoT devices, other visibility components. So now we have much more real-time data that we can take on top of the data that comes from, say, the TMS for the fleet, and leverage that to plan and optimize and make decisions with those simulations of the future. So again, this is a layer of decision making on top of those existing systems and data sets, as well as any other data sets that make sense for decision making, whether it be, other types of inputs that might understand, okay, what loads might pop up in the network, or what loads should I take, accept or reject? Where might I see, let's say, a deficit or a surplus in the network where I might need to, say, fill some trucks because I'm going to have some empties coming up. All of those things you would optimize and plan for with optimal dynamics on top of these existing data sets. So the last piece here, if you look at, how we can go about that, for that strategic simulation, it doesn't even require integration, right? We can show that strategic simulation within a proof of concept. We can do that strategic simulation when we get started with your data set without integration. And then as we move those decisions that you're going to make, say, around driver retention policies into production, that's when we would integrate with those systems, the TMS, the GPS, the ELD, so that as we're making decisions, we understand where everyone is located in the network, all of your trucks, assets, drivers, what's their hours of service, so that as we accept loads based on those driver retention strategies and we assign drivers based on that, we're doing it with a live connection to the TMS and the other real-time data inputs. So with that, I'll go over to Q&A.